In this lecture here, we want to continue in Chapter 1 talking about equations and inequalities by moving into Section 1.2. And in this section here, I'm going to talk about how you solve different types of equations. And so the two equations we're going to work at in this section are linear equations and then rational equations. So our objectives in this lecture is we're going to solve linear equations in one variable, then we're going to solve linear equations containing fractions. That's what this lecture is going to do, and then I'm going to follow this up with a second lecture, second video lecture where I talk about how you solve rational equations with variables in the denominator. So we'll start with the linear stuff, and then I'll move into and I'll follow it up with another quick video that shows you how to handle rational equations. All right, so first off, what exactly is a linear equation? So a linear equation in one variable x. So all the problems we'll do will involve x, but it can actually be any variable. Is an equation that can be written in this form: ax plus b is equal to 0. So the equations that I give you won't start like this. So it won't start in this form. But ultimately what you could do is you could simplify the equation to be in this form. Okay, and so this is where a and b are real numbers, and a it's not equal to 0. And so what I want to do in this lecture here is I want to show you how to solve linear equations. So basically, the way you're going to know you have a linear equation is the variable x is not going to have any exponent. Okay, so there's no exponent with it. So there's no squared term or cubed term, or x to the fifth, whatever, any exponent. It's just x raised to the first power there, 1. All right, so let's solve and let's just check this one. Okay, so we'll start pretty easy. So let's look at 6x minus 3 is equal to 63. Okay, so when you solve this, okay, solving this means you're going to simplify it such that you get x is equal to some number. All right, so what you're going to have to do is you're going to have to undo some operations here. So I have 6x minus 3 is equal to 63. So I want to take this constant and move it to the other side. So to undo subtraction, I'm going to add 3 to each side. So this is going to cancel. I'm going to bring this 6x down, and 63 plus 3 gets me 66. Now I have 6 times x. So to undo multiplication, now I'm going to divide both sides by 6. And this 6 and the 6 will cancel. And you're left with 66 divided by 6. That gets you 11. So you can check this. Like, this is what we're saying here is this solves this equation here. And so you can check it by just plugging it back in. So it was 6x minus 3 is equal to 63. So if I take 11 and plug it back in for x, does it solve this equation? Well, 6 times 11 is 66. Is 66 minus 3 get me to 63? Yes, it does. So it solves it perfectly. It checks out. All right, let's do another little bit easier one. Let's look at 3x plus 5 is equal to 2x plus 13. All right, so how exactly would you solve this, right? So what you want to do here to solve is you want to move all constants to one side. Okay, that's the first thing I'm going to do. So what I'm going to do is I'm going to take this 5 and I'm going to subtract it over to here. All right, so I'm going to subtract 5 from both sides. So this cancels out. Well, what's 13 minus 5? Well, that gets me 8. And then what you're going to do is you're going to move all variable terms to one side. So what I'm going to do is I'm going to subtract 2x. I'm going to move the 2x over to the left-hand side. So this is gone. And 3x minus 2x, that just gets me 1x, or x. And x is equal to 8. And look, you can check this too. Okay, let's take 8 and plug it in. 3 times 8 plus 5 is equal to 2 times 8 plus 13. So 24 plus 5 is equal to 16 plus 13. Does 29 equal 29? Yes, Yes, we solved it perfectly. It checked out. It works. All right, let's do a couple other ones here. So for these remaining problems here, I'm not going to check them out. I'm just going to solve them for you. And then we'll assume I get to do it correctly. So let's solve this one. Let's look at 8x minus, and then in parentheses, 3x plus 2 plus 10 is equal to 3x. Okay, so the first thing you're going to have to do, notice I have this parentheses here. We're going to distribute the negative. So minus 3x minus and then plus 2. Okay, so this becomes minus 2 plus 10 is equal to 3x. Now let's clean this up. Let's combine like terms. 8x minus 3x, well, that gets me 5x. Minus 2 plus 10 gets me plus 8. And this is equal to 3x. So now there's a couple ways you can solve this, right? Okay, so I've got variables on both sides. So let me move this one minus 5x over. Okay, so 5x, I'm going to subtract 5x. So 8 is equal to, so 3x minus 5x gets me minus 2x. So notice how it looks a little weird, like with the variable on the left-hand side. So you can just rewrite this. I'm going to rewrite it as minus 2x is equal to 8. You can do that, okay? Then what do I have in front here? I have a minus 2. So I'm going to divide both sides by minus 2. Negative 2 cancel. And then 8 divided by negative 2 gets me minus 4. So we got it. All right, let's do one more like this. Okay, let's look at 2 times x minus 1 plus 3 is equal to x minus 3 times x plus 1. Okay, so you see what you're going to have to do. First, you're going to have to distribute the value in front of the parentheses. So the 2 goes times 2x. 2 times minus 1 becomes minus 2 plus 3 is equal to x. Now bring this negative with it. Minus 3 times x gets me minus 3x. And minus 3 times 1 gets me minus 3. All right, let's clean it up. Okay, so I have 2x. Minus 2 plus 3 gets me plus 1. X minus 3x gets me minus 2x minus 3. Okay, so let's first start by subtracting 1 over. So this cancels, so I get 2x is equal to minus 2x. Minus 3 minus 1 gets me minus 4. Now look, to get rid of minus 2x, I'm actually going to have to add 2x to each side. So these are going to cancel. 2x plus 2x gets me 4x is equal to minus 4. And then what I'm going to do is I'm going to divide both sides now by 4. So those cancel. And then x is equal to minus 4 divided by 4. X is equal to minus 1. So I hope it helps, like seeing this way to solve it. I think it's a good way to solve. I think if you just take your time and write out each step instead of, don't try to skip steps. It's how you can make a mistake. It should be pretty straightforward to solve. All right, now let's try this. Let's try solving with fractions. Okay, so let's look at this one here. So let's look at x over 5 is equal to x over 6 plus 1. Okay, so the first thing you're going to need to do here is you're going to need to find the LCD. Okay, so 1 is really 1 over 1. Okay, so what is the LCD of 1, 5, and 6? Well, it's actually just 30. So now you're going to rewrite everything over the LCD. All right, so to change the 5 to a 30, I need to multiply by 6. So this becomes 6x over 30. To change the 6 to a 30, I need to multiply by 5. So this becomes 5x over 30. And then look here. To change the 1 to a 30, I need to multiply by 30. So this becomes 30 over 30. Notice how they have the same denominator here, everything. So this, you can even rewrite this as 6x over 30 is equal to 5x plus 30 over 30. Now you're going to multiply both sides by the LCD. So I'm going to multiply this side by 30 and this side by 30. Look what happens. They cancel. So you're just left with 6x is equal to 5x plus 30. Just subtract 5x over. So these are going to cancel. 6x minus 5x is equal to x. And what we're saying here is x is equal to 30 now. It's like, did that work? I don't know. Let's check. So let me plug in 30 for x. So it's 30 over 5 is equal to 30 over 6 plus 1. Well, 30 over 5 is 6. 30 over 6 is 5 plus 1. Yes, look, we got it. It works. All right, so let's try another one here. Let's just solve this one. Let's look at x plus 3 over 6 is equal to 3/8 plus x minus 5 over 4. Okay, so you're going to need the LCD here. LCD of 4, 8, and 6, right? So what do we think this is? I don't know. What do you maybe pause and think here? I think it's going to be 24, okay? So what do I need to multiply the 6 by to get 24? I need to multiply that by 4. I need to multiply the 8 by 3. So 3 times 3 gets me 9. And I need to multiply this by 6, right? So this is 6 times x minus 5 over 24. What you can also see here is once you have the same denominators here, you can basically just cancel them out. And you're just left with 4 times x plus 3 is equal to 9 plus 6 times x minus 5. So it's pretty straightforward to solve here. Just distribute. So you get 4x plus 12 is equal to 9 plus 6x, and then 6 times 5 here gets me minus 30. So I'm left with, I'm going to move this over here. 4x plus 12 is equal to, so look here. So what do we have here? We have 6 minus 30 gets me minus 21. So we have 6x minus 21. Let's subtract 12 to both sides. So I have 4x is equal to 6x. This becomes minus 33. Let's subtract the 6x from each side. So I have minus 2x is equal to minus 33. And then look, when I divide here, this you're just going to leave as is. And this is perfectly okay, by the way. So negative divided by a negative becomes 33 over 2. And you can just you can just leave it like that. That's perfectly fine to leave it as a fraction. And it's okay. I don't want you to think that every answer you get has to be an integer. So you can get a fraction solution. That's perfectly okay. All right, so this is how you're going to be tackling linear equations. I'm going to follow this up next with how you tackle rational equations in another lecture video.